students, today we will be discussing about atomic physics and what atomic physics has. Does atomic physics have a relation with the sun? You can see the sun in the picture, and this is IGCSE Physics video, and we will be discussing primarily what is atomic structure. But before discussing what is atomic structure, let us deep dive what are basically atoms. Because atoms are the building blocks of matter. We know that, we have studied in our classes. In lower grades we have studied that it is the building blocks of matter. And we know atom is, we had thought that atom is something indivisible, but we know that it can be further divided. Atom can be further divided. So this atom which can be further divided, the particles is called as subatomic particles, and they are protons, neutrons and electrons. So we will be discussing a brief about what are atoms, how they are building blocks of matter, what are protons, what are neutrons and what are electrons. And this everything will be covered in atomic physics. We will be getting into the details and how the sun is related to atomic physics. We will be discussing that. So welcome to Ren TUT, and my name is Renny. I am very excited. We will learn something new. Atoms are the building blocks. Now if you can visualize a wall is made up of bricks, right? The bricks are the building blocks of a wall. Okay, so one brick is attached to another brick. You can see atoms are shown in the form of bricks. They are building blocks of everything we see. If we see a solid, we have taken an example of table salt in simple language. It is made up of atoms. If we take liquid, we can take water for example. It is also made up of atoms. If we take a gaseous substance like for example oxygen, that is also made up of atoms. So each and everything what we see in this universe is made up of matter, and matter has the smallest particle which are called atoms. How small is an atom? You can see there is a photo out there. If you take grains of sand in your hand, in your palm, if you take, and you can go to the smallest level, that one grain of sand if you pick, this one grain of sand can be divided into millions of times, then you will see an atom. So atom is a super tiny substance which can be seen through our eyes. Okay, so it is so tiny that you can see on the thumb, there is on the nail, there is a small part of the one grain. The atom is much smaller. So this much small is an atom. So today we will be learning basically the atomic structure itself. We will be getting into the details. Hello students, today we will be discussing about atom. What is an atom? Atom is basically the smallest part of the any molecule. So you can visualize an atom. You are already aware an atom consists of neutrons, protons and electrons. Electrons, they revolve around the nucleus, and in the nucleus there are protons and neutrons. Now if you think about an atom. An atom, if you visualize an atom a size of a football ground or a stadium, then the nucleus will be as small as berries. So it is a pin or point, okay, and the atom is, you can see the radius in the diagram, it is 10 raised to minus 10 meters, okay, and nucleus is much more smaller, it is 10 raised to minus 15, so it comes in femtometers, okay. Previously we had seen how small is an atom and how atoms are the building blocks of matter. Now we will be seeing how the sun has primarily hydrogen atoms, which is getting converted, it changes hydrogen. There is a process in physics, we will be learning that when we go further. Right now, to keep it simple, sun changes somehow hydrogen atoms into helium, okay. So sun, that is why it keeps on glowing regularly. So there is some kind of process undergone in the sun where hydrogen gets periodically, atoms get periodically transferred and they form helium, okay. This all is related to atoms itself, so we'll come back to the topic of the atoms, okay. And atoms, you are aware that atoms are further subdivided, and atoms can be further subdivided. It has protons and neutrons, which are primarily stationary in the nucleus, and electrons, it revolves around the nucleus in orbit, okay. And we will be focusing our area of concern will in atomic physics, and the atomic structure what we are discussing is the strong nuclear force between neutrons and protons, which are situated and which are stationary in the nucleus. So this protons and neutrons are held together by a strong force. Protons are positive and neutrons don't have charge, okay, that you have to keep in mind. Protons are positively charged particles and neutrons don't have any charge. So nucleus consists of protons and neutrons. Now, what keeps the nucleus together? So there is a strong force of attraction between the protons and neutrons. This force is so strong, and the scale, you can see it is in 10 raised to minus 15 meters. So my minus 15 meters, okay, that much small is the it is called in femtometer. So the nuclear force which holds the protons and neutrons together, which we have said right now, it is in femtometer, and these two particles, protons and neutrons, are called nucleons, okay. They overcome, since the proton and neutron, so like for example, proton has a positive charge and neutron has no charge. So in the nucleus, majority is positive, that is why nucleus is positive, and the electrons has negative charge, so that it the force of the electrostatic repulsion between these electrons and the charges which are stationary in the nucleus, that is called electrostatic repulsion between protons and the electrons. So it is the nuclear force between the protons and the neutrons are 100 times stronger and the than the electric force between the nucleus, which is considered positive since neutrons don't have any charge. So these electrons and the positive nucleus what we have is having some kind of a electrostatic repulsive force. So this nuclear force we will be concentrating much more on that. So the nuclear force is 100 times stronger, and you can see there is a small dot, that much is the size of the nucleus. So nucleus is very small, and these particles are so strongly intertwined, and they have so strong nuclear strong force, that you need much more energy to separate them. So that this tiny nucleus, you can see it is condensed in the center of the atom, and most of the atom is an empty space. Okay. Now we will be seeing what are the subatomic particles. As I told you earlier, there are three subatomic particles in um, the atom. Primarily one is proton, the positive charge particle, and it has mass of 1. Okay, that is positive 1. Okay, positive 1, it is situated in the nucleus, and AMU is the atomic mass unit. Okay, for simplicity's sake, we have taken AMU. And then neutron is there, which has no charge, and it is situated in the center of the nucleus. Then we have electrons, which are negatively charged particles, and they revolve around the nucleus. Its mass is very infinitesimal. You can see is 1 divided by, we take a round figure like 1 divided by, instead of 1036, we take it 1 divided by 2000 for simplicity's sake, and you will get the answer is 0.305, and it is multiplied with 1 AMU, and that can be written as U. Okay, so you can see the table out there. The proton is positively charged, it has 1 U. 1 U is basically, you can see it is 1.67 into 10 raised to minus 27 kg. So instead of writing every time 1.67 into 10 raised to minus 27 kg, we are using an abbreviation like 1U. So and a neutron is stationary because it is situated in the nucleus, and it has positively and negatively charged particles. So these two charges, they cancel out each other, and the resultant is the neutron does not have any charge. Okay. So electron, now we will move ahead to the electron. So the electron has minus 1 charge, and the mass, you can see, is 1 divided by 2000. It is 0.305 into U, and U can be you can see is 1.67 into 10 raised to minus 27 kg. So every time, instead of writing 1.67 into 10 raised to minus 27 kg, we are using the symbol for 1U, we are using this symbol. Okay, so this is the subatomic particles. Now we will take a small example of carbon. Carbon atoms, you can see carbon has 6 neutrons and 6 protons, that is in the center of the nucleus. Okay, neutrons and protons are in the center, and there are 6, since we should be aware of one rule. We will be discussing what is that rule. First rule is that number of protons in any element. Now we are taken for example carbon atom. So in all the elements, number of protons and number of electrons, that is the rule number 1, which is always equal. Okay, number of protons, rule number 1 is that number of protons and number of electrons are always equal. So in the carbon atom, you can see there are 6 protons and 6 electrons as well. So electrons are revolving in the shells. First shell contains 2 electrons. Second shell you can see, if you minus from 6 electrons 2, the remainder is 4. So the rest remaining is in the second orbit, you can see. So in the second orbit there are 4 electrons. Okay. So now coming back to the rule number 1, we had discussed that first rule is that you need to remember is number of protons is always equal to the number of electrons. And now coming to the nucleus part, you know in the nucleus there are protons and neutrons. So this constitute the nucleus. Now protons being positive, it has 6 plus charge, and neutrons it has no charge, so it does not have any charge. So if you add these two, protons and neutrons, you will get 6 plus charge in the nucleus, which is stationary. And now coming to the electron part, when the electron is revolving in the shells or the orbits around the nucleus, you can see it is negatively charged particle. One electron is negatively charged, so there are 6 electrons, so 6 into minus 1, so you will get minus 6. So the carbon has no charge at all. Why? And it is electrically neutral. That is why, because in the center it is having 6 plus charge, and these electrons are revolving around the nucleus, it has 6 minus charge. So this 6 plus and this 6 minus cancel out each other, and the resultant is any element. You will see in this case we have taken an example of carbon atom, does not have any charge. In physics we say it as electrically neutral. So most of the atoms you can see, we have shown just for comparison purpose. You can see helium has 2 protons, and you can see the electrons are also equal. Now copper, if you come to the copper element, it has similar protons and similar electrons. Now if you come to cobalt, another element, you see the protons and the electrons are same. Iodine, if you see another element, it has 53 protons and 53 electrons. And germanium, respectively, you can see 32 protons and 32 electrons. So these are the small differences what we have. Firstly, you need to keep in mind the rule number 1. Rule number 1 is that number of protons will always be equal to the number of electrons. Second thing you should keep in mind is that in the center of the nucleus, the protons will have positively charged particles, and the neutrons has no charge. So always the charge of the proton will be if you add these two, you will get positively charged protons. Whatever the number of protons is there, you have to multiply that. Then you will see that any element, if you take the positive charges in from the nucleus and the negative charge from the electrons, they most of the times they cancel out to each other, and that is how every element is stable and they are all electrically neutral. Okay, so in this we have learned how all elements are electrically neutral. Now we will be discussing what are shells, electron shells. So before coming to electron shells, let me give you a brief once again. Protons and neutrons are located in the center of the nucleus. Okay, and nucleus is very small as compared to an atom. We have seen that. Now coming to the main topic, electrons in an atom are arranged in certain energy levels, so which are called shells or orbits. It is arranged in the first orbit, the second orbit, the third orbit. Electrons can be arranged similarly. So every orbit it keeps on moving ahead, it has energy levels. Okay, so protons have positive charge particle, and neutrons are no charge, they don't have any charge, and electrons have negative charge. Now we will see the first shell which is near to the nucleus will have maximum number of 2 electrons, will hold maximum number of 2 electrons. This is for the first energy level where n, or the orbit level, is equal to 1. So maximum number of electrons in the first energy level is 2 electrons. Then we have you can go to the second energy level where n is equal to 2, and maximum electrons which can be stored over there is 8. Okay, and then we have the third energy level where n is equal to 3, and the maximum number of electrons which can be stored in the third energy level, or n is equal to 3, or the third orbit, is 18. Now this keeps on going ahead. Okay, now you can see these electrons which are revolving round an orbit, or the electron shells, we call it electron shells, or we call it orbits. It is all one and the same. Okay, and the nucleus, you can see, is the nucleus, the first electronic the first cell is n1, n is equal to 1, then the second would be n is equal to 2. So in this, what we have learned is that protons are positive electric charge particles, electrons are negatively charged particles, neutrons are neutral, they don't have any charge, and in the nucleus there are protons and neutrons. And we have learned from this is that there are electron shells round the nucleus. So first shell has the first energy level, the second shell is the second energy level, the third is the third energy level, then we have fourth, fifth, so on and so forth. Now we will be learning what is an atom and what is an ion. We have already discussed an atom is always electrically neutral. Why? Because the number of protons and it has same number of electrons. So the number of protons defines what the element is in atom. Now coming to ion, what is an ion? Ion is neutrally charged. Different number of protons and electrons are there, and it may contain one or more atoms. We will be seeing what is an ion. There are two kinds of ions. One is the cation and second is the anion. Ion with positive charge is called cation, and ion with negative charge is called anion. Now we will learn what is a cation first. You can see sodium atom out there. Sodium atom has electronic configuration, electrons. In the first orbit you can see 2 electrons. Here we have drawn only the last orbit. So the first orbit is not drawn over here, which has 2 electrons. Second orbit is also not drawn over here. The third orbit is having only 1 electron in the sodium atom. Okay, this is called the valence orbit. Okay, so this orbit we have drawn only. The first and the second orbit we have not drawn. Directly we have drawn the third orbit, and you can see the nucleus in the sodium atom. Now what happens is that due to some reason, if you pass energy and you excite the atom, the electrons shift from the sodium atom and it moves outside. So you can see as a sodium ion is formed now. You can see the arrow is marked, and you can see on the right hand side sodium ion is there. So 1 electron has gone out, so that is the reason why we get positive charge 1. Okay, positive charge 1. So this plus 1 is called, since it is having plus symbol, it is called a cation. Now this plus 1 positive symbol plus an electron is freely moving outside. Let us take another example to understand what is an ion. Let's just take fluorine example. So fluorine, you can see fluorine electronic configuration is first orbit, it has two electrons we have not drawn over here. Directly we have drawn the last orbit, that is valence orbit, valence shell orbit. Okay, so it has 7 electrons. So you can see fluorine has 7 electrons in the last orbit. So in this case what happens is that it can't send all the 7 atoms outside the atom. So in order to maintain that octet level, octet in a sense, you have to complete that 8 octet level. So octet configuration. So the atom can accept the electrons from outside, and it can accept, in order to attain 8, the fluorine atom has to accept any one electrons from outside. So suppose from the sodium ion, it is ion and plus 1 freely moving electron is there. So that one electron, suppose it comes and joins the fluorine atom. Now this electron has come from outside and has joined the fluorine ion. So ion, now the fluorine atom has excess electrons. One atom has come from outside, so it will attain a minus. How many electrons have come? 1 electron. So that is why minus 1, it will attain a negative charge. So this is how a fluorine ion is formed. And now fluorine ion can be taken a best example for anion. So for cation we had seen the example of sodium ion, and for anion we had seen an example of fluorine ion. So again, coming to the sodium atom, we had discussed that it lost an electron. So once it lost an electron, so the sodium ion is formed. Now one electron has gone outside, that is why my plus, it has got the plus, it has excess number of protons then. So that is why this one electron has gone out, that is why it will get the positively charged. So one electron, since it has gone outside, it will attain plus 1. And similarly fluorine atom, we have seen from outside one electron had come inside the fluorine atom, where in the outside outermost shell it had 7, and when it took from outside one electron, it attained 1 electron from outside. That is the reason now here the proton is, you can see it remains the same, but number of electrons are more. So electrons are more, that is the reason why negatively charged fluorine ion is formed. Now we had previously seen rule number 1. Rule number 1, what it states, it is that number of electrons is equal to the number of protons. We had seen prior to this that how positive charges and negative charges, why the atom is neutral. So we will be discussing that once again. Okay, to summarize everything what we have learned previously, why the atom is neutral. Because of the positive and negative charge. You can see the pot, you take an example, a simple example of hydrogen atom. Hydrogen has 1 proton and 1 neutron in the nucleus. So 1 proton has having positive charge, and neutron doesn't have any charge. So in the nucleus we have plus 1 charge. So that is why we have represented it P is equal to plus 1. Now you see an electron, one electron is revolving in the first orbit. So that is electron. So electron has minus charge. How many electrons are there? Minus 1. Okay, so 1 is there, so that is why E is equal to minus 1. So this protons, they have positive plus 1 charge, and electrons have minus 1. So these two cancel out. So that is the reason why hydrogen atom is neutral. Now what are ions? Ions we had seen previously. We have cations as well as anions. Let's take an example of sodium once again. So you can see the number of protons is 11 in the nucleus, and neutrons it is uh, having no charge. So this plus, if you add protons and neutrons, the nucleus will be having more positive charges of protons. That is why it is shown P is equal to plus 11, and electrons is minus. You can see we have drawn only the last orbit. There are 3 orbits out there, first, second and third. So we have drawn the last orbit, wherein one one electron is revolving around the third orbit. So you can see always according to the rule number 1, number of protons is always equal to the number of electrons. So that is the reason why we will be putting the number of electrons is equal to minus, and how many electrons will be there, since the rule number 1 states number of protons is equal to number of neutrons, so it will be automatically 11 itself, and E is equal to minus 11. Now the protons plus 11 and the minus 11 will cancel out each other, and that is why you can see the sodium atom is now showing a net charge of 0, and this is called atom is neutral right now. So we are discussing how it will become an ion. So let's take the last orbit. One electron is revolving in the last orbit, third orbit. Now if you excite the electron, it goes outside the atom, and when it goes outside the atom, you can see it, since one electron has gone outside, it will attain plus 1 charge, and you can see in the figure number of protons is plus 11, that is there in the nucleus, and electrons has decreased, you can see. So electron is equal to minus 10. So if you minus protons, the positive 11 minus electrons, the negative 10, you will get positive 1 charge. So this is how we get ions. So ions, once the here in this case the electron has gone outside the atom, that is why it attains the positive charge. If for example, due to we have seen before, due to some reason, like for example we had taken an example of fluorine, it took 1 electron. If it gains, fluorine atom gains 1 electron, then it will attain, since the electrons are more, so it will attain minus 1 charge. So what is rule number 1? We are just discussing that once again. Number of electrons is equal to the number of protons. And rule number 2, we have seen protons have positive charge, neutrons does not have any charge, and the total charge in the nucleus is positive. Net charge, the total charge in the nucleus is positive. The negative charge of the electrons and the positive and the negative charge, they cancel out each other. So that is why atom is electrically neutral. The third rule what we have learned is that if an atom loses an electron, then that atom will have positive ion, that is called cation. And if an atom gains an electron, like we had seen in the example previously of fluorine, it gain an electron, then that atom will have negative charge. negative charge, that is called negative ion, that is called anion. So cation, positive charge, has more number of protons than electrons, and anion, negative charge, it shows negative charge. In that case, in anions, the electrons are more and the protons are less. This is what we had discussed. We have discussed very briefly about atomic structure, where we had discussed about of the subatomic particles, and we had discussed about what are ions, and we had discussed what are electron shells and the energy levels in brief. Thank you for watching. You have a nice day. Thank you so much.